Hello friends, welcome to Power Electronics. Today we will discuss the Thyristor commutation techniques. Before that, we know that a thyristor has PN layers and it has three junctions J1, J2 and J3. In the forward blocking mode, junction J1 and J3 are forward bias, junction J2 is reverse bias. So it is having an avalanche breakdown. Also we give the gate pulse from here so that it break down easily and thyristor starts conducting. So here we discuss the thyristor commutation techniques. Thyristor turn off. Commutation means to turn off. There are two methods. First is the anode current fall below the holding current. As I have already discussed that anode current, that is minimum current below which thyristor stops conducting when the gate circuit is removed. Second is reverse voltage is supplied across the thyristor so that it again gains the reverse blocking capability. So commutation is defined as a process of turning off the thyristor. The use of thyristor in the low circuits is not used because of the advancement and we use GTOs and IGBTs. But thyristor is still popular. For higher voltage and higher current applications about 1 kV and 0.5 kiloampere, thyristor circuits are often used. So the thyristor commutation techniques is called as class A commutation technique. It is also called as load commutation or resonant commutation or self commutation because it turn off itself. If we see in the diagram that Vs is the source voltage, that is DC, we have SCR, thyristor and LCR are connected in the series. If the value of R is low, then we connect it in series. But if the value of R is high, then we connect C and R in parallel along with an inductor. So the essential requirement for the both circuits is that the overall circuit must be under damped. When these circuits are energized from DC current waveforms as shown in the diagram, it is seen that the current first rises to the maximum value, then it begins to fall when decays to zero and tends to reverse the thyristor by turning off the thyristor. Load or class A commutation is prevalent in thyristor circuit supplied from a DC source. The nature of this circuit should be such that when energized from a DC source, current must have natural tendency to decay to zero for the load commutation to occur in the thyristor circuit. Also, we should remember that load commutation is possible only in DC, not in AC. The reason is that it should underdamped and go to the value of 0 so that thyristor turn off its own because there are charging elements L and C like in tank circuit. It charges and discharges and make the this SCR turn off. I will explain this with an diagram. If you can see here Vs is the source voltage. Here it is SCR or you can called as thyristor with L and C connected in series. When we provide supply, thyristor starts conducting, then it passes through inductor and then it goes to capacitor and return path. Now if we understand it by the graph, when the thyristor starts conducting, it behaves like an short. So if you can see here, the voltage across the thyristor is 0 because it is short circuited. Whenever a circuit is short, that means voltage across is 0. Then if we see the if we apply KVL here, what equation we get? We get minus Vs plus L di by dt plus 1 by C integration of I dt equal to 0. Take Vs to that because it is minus, So it will become Vs equal to L d by dt here. From that we calculate It, which is the current. Is equal to root C upon L sine omega t, where omega is the resonant frequency. So when this current passes through L and C, first of all it rises slowly and reaches the maximum value. Why it reaches slowly? Because of inductor. Because inductor has a property that it does not allow sudden change in the current. So that is why in graph it rises very slowly and reach the maximum value. Which maximum value? That is It equal to Vs under root C by L sine omega t at the time period of pi upon 2 omega naught. At that particular time, how the capacitor behaves? Capacitor starts charging to the value up to the source voltage. At that particular time, thyristor is 0. As I have already discussed, it behaves like an short circuit. After a particular time, it starts discharging and reaching a period pi upon omega naught. Before the capacitor was before the circuit was turned on, capacitor was already charged to value of 2 Vs. How it is charged? It was already minus Vs and the polarity was previously minus plus. So minus equal to 0. So it is 2 Vs before we turn on the circuit. At now particular point of time, pi by 2 omega naught time period, it charges up to value Vs. As we have given, it passes through the thyristor, then inductor, and then the capacitor charges to the value of Vs. Now we have seen these underdamped oscillations and it reaches the zero. Now it is going in the reverse direction and slowly it is going to zero. Then it reverses and the capacitor starts discharging. It discharge in the and reaches a point zero. At that particular time, the thyristor is still zero because it is already short circuited. It is in the conduction mode. Now if we see in the diagram that when the thyristor is was not turned on, it has value of 2 Vs. Now the thyristor stops conducting, minus Vs. So Vs is the voltage across the thyristor when it is turned off. I will again explain that when we apply voltage Vs, the current passes through thyristor, then it reaches the inductor, then it passes the capacitor and negative path. Up to a particular point of time, it starts rising slowly because of the inductor. Then capacitors charge to the value of Vs. After that, these signal get underdamped that it reaches a value 0. Now the capacitor was already charged, it start discharging through the inductor and discharge through this SCR and make this SCR turn off. Now the thyristor at that particular point of time, that is pi upon omega naught, this thyristor stops conducting and it behaves like an open circuit. It behaves like an open circuit. If you can see here, I will explain here. So it behaves like an open circuit. So these Vs appear across it. This Vs appears across this. So when the thyristor gets turned off, the Vs will be the source voltage across it. So this is the explanation of this. Thank you very much.